All right, let's just jump right in. The digital world as we know it is being pulled in three completely different directions by three computing powerhouses. You've got the raw, brute force strength of high-performance computing. Then there's the blink and you'll miss it reaction time of edge computing. And finally, the one that changes all the rules, quantum. So that begs the question, right? Which one of these giants is going to come out on top and really define the next decade of tech? Is this a straight-up battle for number one? Or is there something a little more interesting going on? Let's dig in and find out. So first up, we've got the seasoned veteran, the heavyweight champ, high-performance computing, or HPC. The best way to think about this one is as the marathon runner of the computing world. It's not built for quick sprints. Nope, it's built for insane endurance, for tackling calculations so big they can take hours, or days, or sometimes even months. So how in the world does it do that? Well, it all comes down to a concept called parallel processing. See, instead of one single processor just chipping away at a huge problem, HPC works like a massive, perfectly orchestrated army. It takes these enormous tasks, shatters them into tiny pieces, and then gets millions of processors, we call them cores, to attack all those pieces at the same time. The goal isn't a fast response, it's all about maximizing what we call computational throughput, just getting that entire gigantic job done. And the jobs it tackles? Well, there's some of the biggest challenges humanity is facing. I mean, we're talking about creating unbelievably accurate climate models, simulating the mind-bending physics of fusion energy, designing new drugs one molecule at a time, and even modeling how entire galaxies are formed. These are problems that your standard computer just can't even begin to touch. To really get your head around the scale, look at this number. Over 11 million. That's the total number of processing cores inside a single supercomputer, El Capitan, all working together. This isn't just a small step up, it's a completely different kind of machine. Okay, so now let's completely switch gears and look at our next contender. This is edge computing, the reflex specialist. If HPC is our marathon runner, edge is the Olympic sprinter. It is built for one thing and one thing only, pure, instantaneous, real-time speed. The whole philosophy behind edge is actually pretty simple. Physics has a speed limit. Instead of sending data all the way to a distant cloud server and waiting for a response, edge computing acts like a local brain. It processes information right there, on site where the data is actually being created. And doing that, well, it dramatically slashes that delay, which in the tech world we call latency. And that's super low latency. It's absolutely non-negotiable for the technologies that are literally shaping our world as we speak. Think about it. An autonomous car can't afford to wait for a signal from a server hundreds of miles away to slam on the brakes. Smart cities have to manage traffic and utilities in the blink of an eye. Edge is what makes those instant decisions possible. So just how fast is instant? For something like facial recognition, the goal is to process everything in 370 to 620 milliseconds. And that's not some random number. That's about the speed of human perception. The whole point of edge is to give our technology human-like reflexes. And now for the wild card, the one that doesn't just play the game differently, it completely rewrites the rulebook. This is quantum computing, the ultimate rule breaker designed to solve problems that we honestly thought were impossible. So what's the magic trick here? Well, you have to forget everything you know about the simple on or off bits in classical computers. Quantum uses something called qubits. Okay, picture a classic bit as a light switch. It's either on or it's off, 1 or 0. A qubit, on the other hand, it's like a dimmer switch. It can be on, off, or kind of somewhere in between, a blend of both, at the exact same time. This weird state is called superposition, and it's what lets quantum computers explore an unbelievable number of possibilities all at once. The potential here is, it's just staggering. There's an algorithm called Shor's algorithm, and with it, a powerful enough quantum computer could theoretically break most of the encryption we all rely on every single day. But on the flip side, it also promises incredible breakthroughs, like simulating molecules with perfect accuracy to discover new medicines and create revolutionary new materials. But this kind of mind-bending power comes at a serious price. You see, qubits are unbelievably fragile. The slightest disturbance from the outside world, a little vibration, a tiny change in temperature, we call it decoherence, can completely wreck the calculation. To stop that from happening, some of these quantum computers have to be kept at around 20 millikelvin. That is colder than deep space. Okay, so we have our three contenders: the marathon runner, the reflex specialist, and the rule breaker. And it looks like a classic showdown, right? But here's the twist. The real story, the one that's actually going to define our future, isn't a competition at all. It's a collaboration. When you really boil it down, each of these architectures has one main mission, one thing it's obsessed with. HPC is all about maximizing throughput, getting the absolute biggest job done no matter how long it takes. Edge is obsessed with minimizing latency, reacting as fast as physically possible. And quantum? It's all about unlocking that exponential potential for very specific, very, very hard problems. This chart here really lays it all out. Look at their current state. HPC is established. It's the bedrock. Edge is growing like crazy with things like IoT and AI. And quantum, it's still pretty much experimental. When you look at it this way, it becomes really clear they aren't even trying to do the same thing. And this quote, this really gets to the heart of the whole thing. The future isn't about one of them winning, it's about how they're all going to fit together. It's all about synergy. We're moving towards a future that some people are calling quantum-centric supercomputing. Picture this. You've got these massive HPC systems providing that brute force foundation. Then you have specialized quantum coprocessors literally plugged into them to handle the impossible calculations. And all of that is connected to a huge network of edge nodes that are out there interacting with the real world in real time.
So you see, the ultimate future of computing, it really isn't a competition.
At the end of the day, it's a collaboration, where each of these absolutely incredible technologies works in harmony, creating a single, unified, intelligent fabric that connects everything from the biggest supercomputer right down to the tiniest sensor in your home. Which brings us right back to our original question, but now with a whole new way of looking at it. It's not about which architecture is going to win. The real question is, which part of this team do you think will see the biggest breakthroughs and change our world the most over the next 10 years? Is it the reliable power of HPC, the real-time speed of edge, or the crazy, disruptive potential of quantum? The future is being built right now.